Okay, like I said, we need two PC. Here's your PC, PCA, PCB, and one wireless router. Wireless router. Is this wireless? Wireless LAN, LAN. Is this what I need? Let me see. Zoom. No, this is not what I need. This is what I need as well. Okay, I think I can make use of this MC. Is that another one? No. Wireless. Oh, wireless router, not wireless switch. Sorry. And you guys are looking at. Are you guys in this class at all?
Yes, sir. Yes, sir.
Aha, okay. Follow me, please. The said objectives. Part 1, set up the network topology tonight only. Identify cables and ports for use in the network. They have given us the IP address already. The time is coming, the IP address will not be given to you. You have to determine the IP address and configure it. Now enter the static IP address information of the LAN interface of the host. Verify that PCs can communicate using the ping utility. Okay. Networks are constructed of three major components: hosts, switches, and routers. In this lab, you will build a simple network with two hosts and wireless router with at least two switch ports. Okay, you will apply IP addressing for this lab. You require resources: one wireless router with at least two switch ports, two PCs, and two Ethernet patch cables. Okay, instruction part 1, set up the network topology Ethernet. In part 1, you will cable the devices together according to the network topology. Power on the devices, power on all the devices in the network topology. Okay, let's do that now. Let's get our wireless router. Yes, this is our wireless router. Yes, correct. Okay, now we need to power it on. Okay, zooming is off here, so we power it on. Where is on? Okay, so trying to power it on now. Okay, this light is supposed to show green. Let's go to the system and power the system. Okay, the system is on. You can see green. How about the second PC? Is it on? This off, so it's on too. So let's change the name: PCA, PCB, PCB. So what's the instruction saying? Now connect one end of an Ethernet cable to the NIC port A on PCA. Connect the other to a switch port on the wireless router. After connecting the PC to the switch port, you should see the light for the switch port turn amber and then green, indicating PCA has been connected correctly. Repeat the same for B. Then after cabling the network devices, take a moment to carefully verify the connections to minimize the time required to troubleshoot issues later. Okay, then after that, to configure, let's do this. Let's get our cable. Like I told you, this is where you get your cable. This end that look like lightning. We look for a straight through cable. This is a crossover cable. This fiber, this phone, this coaxial, this serial cable. This is octa. and all that. So we use a straight through cable. So click here, fast Ethernet 0, put it on any one. This is Ethernet 1. Do the same thing here, fast Ethernet 0, put it here, Ethernet 2. So you see we have amber light now, so it should turn to green. When it's turned to green, then we know that our networking is good to go. Okay, let's wait while it turns to green. Just few minutes, it should turn to green. Okay, correct. PCA has turned to green.
Sorry, sir. Please, why does it take a while before it turns to green?
That is normal. That is normal. It's just like when you are trying to put up your this thing, your DSTV cable. Do you understand? It's normal, but it could be faster
Okay,
than
sir.
one another, depending on the memory of the system.
Oh, okay, sir.
It could be faster sometimes, depending on the memory of the system. But you don't expect it to turn to green immediately. You should first of all show that amber light, then before it turns to green. Is that clear now? Okay, so let's go with the instruction. Let's go on. Now, the instruction here, I will copy, okay, it's even on your portal. The instruction here is based on if you are doing a physical topology, you are connecting two pieces together using Windows 10. But here we are using, what is it now? We are using simulation software. The instruction says to configure the network setting on PCA, click Start. You know, when you come here on your simulation software, you cannot see Start. The only thing you can see is to click on it and it will take you to config desktop and the rest of it. That's where you go. Okay. But here it's saying that click Start. That is if you are connecting at home or in your office with your physical software, this is the instruction you go about it. So if I were you, you can copy it in case your boss asks you, or maybe you're an intern, or you just get employed as a network engineer, and you have to configure the pieces for the first time. So this is the procedure you go through. If you are as a network engineer, you are asked to connect. Maybe they just buy a brand new laptop or a brand new desktop for one of your accountants or your procurement manager or your HR when you want to connect it to your network. This is the procedure you go through. You go to Start, you click Settings. After Settings, you go to Network and Internet. Then you go to the left pane, select Ethernet, click Change adapter options. After that, you right click Ethernet 0 and select properties. Then select Internet Protocol 4. That's IPv4, which we are using now. Select your properties. Right? Click on properties. Then your Internet IPv4 to display the properties window. Okay. Now F. Click the use the following IP address. IP address radio. That's you are doing physical topology real time. So the IP address we have here for PCA is 192.168.1.0, while the subnet mask is 255.255.255.0. So let's go to PCA on our simulation software. We go to IP configuration, we go to static, this IPv4 address. No, there's difference between IPv4 and IPv6. At this elementary level, we are treating IPv4. When we get to the advanced, we'll be talking about IPv6. I think before the end of this class, we'll be talking about IPv6. So you see that the subnet mask has automatically fixed itself. So you close that. You do the same thing for um, the PCB, which PCB is if you look at it, is 192.168.11. So Let's go there. Okay, PV, PC, PCB dot 11. Okay, you have that. That's we have assigned IP address for PC A and B. So the next thing is to confirm our. We need to confirm our connectivity if it is right or wrong through pinging and trace routing. So let's ping it first. Now verify PC settings and connectivity. Use the command prompt to verify. From PCA, click start and search for command prompts. We know where to get our command prompt as using simulation software. So what we do now is we type ipconfig/all command. This command displays the PC host name and the IP address. Let's do this. We have done this before, but the sake of emphasis, let's go there. Command prompt. Okay. ipconfig space/all. So this has given us all the details we need. Okay. So we got to hey, I have to finish this in the next 50, I have to finish this class in the next 10 minutes. Okay. Now, all right, we got to ping now. We ping 192, we ping PCB from PCA. Now, if you type ping PCB from PCA, PCA will not understand. What PCA know about PCB is 192.168.1.11. That's your address. So let's go to PCA. Okay, PCA. We want to ping now. We go to command prompt, then ping. What's the address again? Somebody help me. Is Bakari there?
192.
192 dot what?
168.1.0
Are you sure?
for PCA, right?
Yes. Dot one dot
Yes,
one
yes.
zero. Not dot one dot zero. 192.168.1.10.
But one
Oh, that's PCA. Oh, I cannot ping PCA from PCA. Sorry. 192 ping 192.168.1.11. I'm pinging PCB from
yeah,
PCA.
that is dot one.
Yes, see, we have 0% loss. So we do the same thing from PCB. All right. ipconfig/all. Okay. Now we ping 192.168. Dot what? Dot one dot 10.
Dot one dot one. Yeah.
Yeah, thank you. So our pinging is correct. So that means our connection is right. So we are good with that. Okay. Then, if you are doing this on your system, note this: if your ping is unsuccessful, there is a good chance that Windows Firewall is blocking ICMP. So go and reconfigure your Windows Firewall to be able to ensure your pinging. So this is what this exercise is all about at this point. But before we finish, let's go to trace routing at the same time. So now under trace routing, we're going to use our system to do that. Now determine network connectivity to a destination host, trace a route to a remote server using trace route, data travels and all that. Trace route is what we use under Windows. If it's Unix, Linux system, we use TRACE to trace route. Okay, instruction from part one, we want to trace route some um some we want to ping Cisco from your system. Okay, let me stop sharing this. I'm going to enter my command prompt, CMD. That's from my system now. I'm doing this from my system now. You should be able to see my command prompt now. That's from my personal system, not from Packet Tracer now. You can see Joy Benga. So I'm going to change the directory. Change the directory. Change the directory dot dot cd dot dot. Okay, so I'm on my C prompt now. Okay, so I want to ping Cisco from my system. Cisco.com. Yes, it didn't respond yesterday. Let's see what happened today. 0% loss. Okay, fine. It responded today. Good. So let us ping one of these addresses. Ping www.afrinic.net. All right, let's see what happened and we'll tell you the reason why it happened. Request time out. You see that they are trying to tell us on the instruction that at the time of writing, the European ERIR www.ripe.net does not reply to ICMP echo request. So these sites are not meant to respond to our echo request. Traceroute is regarded as an echo request in IT, so it's 100% loss. Let's clear our screen. Okay, let's go. We got to trace. Okay, we want to trace route cisco.com. Let's trace route cisco.com. I want to be sure you are seeing my command prompt. Okay, now trace route cisco.com. Trace route. I'm using Windows, so I'm using TRACERT. www.cisco.com. All right. So you understand what trace routing now means, the difference between trace routing and pinging. So my system will soon go off, and but I believe we'll be able to finish before that time. Just to explain this last step. Now, traceroute will tell you each step it takes from your end to the end of the server you are trying to trace, you are looking at. You can see that we're able to get some from 1 to 4 to 5, but 6 is timed out, it's not connecting, 7 is not connecting. That means server 6 and 7 is done, 8 is connected. This is trace routing. So you lost your at point 6 and point 7, you lost your connection. Okay, right. Step 11, let's see what happened there. What's going to happen at step 11 is successful, 12 is successful as well. Okay, just need to do this with you guys. This is where the network cut us out yesterday. So after this, I think that's all after this. So now let me just read this. Now perform a trace route to one RR. Okay, let's do that then. B, a web-based who is tool is found at tracerouteonline.com. We'll go there now. It can be used to determine the domain's travel from the source to destination. List the domains below from your trace route results using a web-based WHOIS tool such as tracerouteonline.com. Trace complete to Cisco. Now let's do the last two exercises. We got to trace route Let's trace route. Um, let's use Appnik this time, appnik.net. Remember the other time we tried to ping, it did not respond. But for trace routing, it's responding.